we'll get to see some pictures of the newest addition to AOT here in a moment. And then we have Brian and Adam over here doing the most important part, keeping the show up and running. And that's everybody, so let's go on to Michael.
All right, so many of you already know this, but I'd like to do it each time. What is Astronomy on Tap? Well, it's a worldwide phenomenon. We have locations all across the globe. It started just over 10 years ago in Brooklyn, New York, and our own location is now about just over 5 years old, so good for us. And specifically here in San Antonio, we like to have fun. It's a requirement. We love to have fun. I felt the fun energy. We like to keep it interesting. Both of our talks tonight, I hope you both enjoy them. They're going to be, ranging in different topics, and every time we always have great speakers. They are interactive because you all will get to ask questions. At some point, a phone number will be on this television screen here where you can text in your numbers. We can also pass around the microphone if need be, but feel free to ask any questions you may have. And a chance to win. That's right. We will have trivia at the end of the night. For those of you that can stick around, we will have a fun trivia. We've got some great prizes tonight, including some prints from the moon that Robert Reeves will tell us about a little bit later, as well as some Eclipse book and tumbler and cool stuff related material. So stick around for that. And as always, please check us out on our socials. We try to keep updated on photos of each event, but we always, on socials, will let you know when the next events are and keep you updated on any other fun astronomy news as well.
All right. Hello, everybody. Today, we're going to start with some announcements, and then we're going to get into our first talk about eclipses. We got that big eclipse coming up. I've not heard about it. By Dr. Lindsay Fuller. Then we're going to have a 10-minute break, and then Caleb will give us astronomy in the news. And then our last talk is titled Cosmic Giants. I don't know what that's about. By Dr. Dana Koeppe. Galaxy clusters. So our first announcement is actually some sad news. So originally we were going to have Dr. Harold Linartz present at this Astronomy on Tap, but on New Year's Eve he passed away unexpectedly. So it was very sad. He was from the Netherlands, and a recent Southwest Research employee brought that connection because Harold was her advisor. So he was a chemist, but at heart he was a outreach professional. He would often write press releases, radio interviews, and he would do many newspaper contributions, including those to his local small Netherlands hometown, just on the night sky to try and get people interested. So we're very saddened by this. However, the circle of life seems to have its way. Our next news is very exciting.
Yeah. Our newest addition, Finley, was born on January 15th, very early Friday morning at like 6 something in the morning. I don't remember the exact minute, but very early, bright and early. And so we'll be getting him out here talking pretty soon. And first up, we have Dr. Lindsay Fuller. She received her PhD from UTSA in 2017 and is currently teaching faculty in the Department of Physics and you are teaching the faculty, or you are a yeah, you are a, yeah, okay, that's what I thought. Just want to double check. Yeah, she is teaching faculty in the Department of Physics and Astronomy, while her dissertation and research involved in observing the environments around supermassive black holes in infrared wavelengths. She is currently the Eclipse project manager at UTSA for this academic year. Everybody give it up for Dr. Lindsay Fuller. Oh yeah. So for the first timers, we have something called a drinking word. So the presenter will say some word designated that we will hear in a moment, and when that word is uttered, we woo! And what is your word?
My word, is this on? No. Okay. My word is total. Hey!
Drink responsibly. We only have one dolly to carry
It's
you
not
out here.
that bad. Okay. So hi everybody. My name is Lindsay Fuller. I'm at UTSA, and normally I'm doing research or teaching at UTSA, but this semester they have my department chair, Angela Speck, has carved out a position just so I can be in charge of Eclipse things. And since we just had an eclipse in October and we have another one in April, I just wanted to tell everybody like the things that we have been doing at UTSA for both the total and the annular eclipse. So obviously I know we've all, or almost all of us have seen this before, but just in case you're a newcomer and you've never seen this image before ever in your life, we just had an annular eclipse that came through San Antonio in the Hill Country, and we're gonna have a total eclipse that comes, didn't even mean to. We're gonna have that one in April that comes through the Hill Country. Keep in mind, everyone, that only half of San Antonio is in totality. So the southeast part of town will not be, but the northwest part of town, which includes UTSA, will be. And I won't say it again. So for the annular, where were we? Where were UTSA and some SWERI students? Where were we for the annular eclipse? So I was in Fredericksburg along with some colleagues at this table over here, Chris, Lisa, Mark. We were at a winery up in Fredericksburg, just, it was hardship, but somebody has to do it, And then we had a bunch of, several students that were at Garner State Park. Sam was at Garner, Michael was at Garner. I think those are the only people in attendance that were at Garner. UTSA, we were supposed to have a nice big event at the Alamo Dome on Eclipse Day because there's going to be a UTSA game at the Alamo Dome. However, we found out a week beforehand that the game was going to be at 7 p.m. The eclipse was at noon, and that's a really long time to tailgate from 11 a.m. to 7. So they had to, they had to kind of redo the event, and so we held it on the campus. And so that was the official UTSA event. Several people were at Mission San Jose, Caleb, Michael, Milcar, San Antonio Zoo. We have Sebastian back there. Boeing Techport, one of our faculty was at Boeing Techport. Valley of the Gods, Utah. One of our grad students was invited to Utah to work with Univision to film from Valley of the Gods. And then we have Tracy, who is normally here, and then I don't know who else went to Scobie, but there were a lot of people at Scobie too. So that's where we all were for the annular. And so I kind of want to highlight the Uvalde County Stellar Fest because I was partly in charge of organizing some of that event. So basically Uvalde County had events in Uvalde, Concan, and at Garner State Park. And what I did was to organize some of the events at Garner State Park. And actually for the annular eclipse, I drove to the San Antonio airport, gave somebody a ride to Uvalde, went to Garner, stayed overnight outside of Garner, got up, went to the park, drove to Fredericksburg, was in Fredericksburg for the annular, drove back to Garner, and me and Michael were at Garner on that Sunday. So it was a busy hill country weekend for me. This is, hopefully the video works. This is a video from Garner from one of our faculty at UTSA. You can see it was a little bit cloudy at Garner. I heard that it was a little bit cloudy in San Antonio too. Up in Fredericksburg, we had the fortune of having some pretty, nope, that's not what I meant to do. There we go. In Fredericksburg, this is some of the images that I got just with my phone. So the one on the left, this was part of annularity. You can see, I think that's Bailey's beads over on, yeah. And then, and then up here, we just have some different, so that's just a white light filter there that taken with my phone. This is Mark's hydrogen alpha filter here, and you can see a little bit of a solar prominence right here at the bottom with his hydrogen alpha filter. And then I just have a few other images here taken from the annular, and then that's one of our sun spotters up at the top. So other projects that we had for the annular that I was a part of. I mean, our students and faculty were all parts of several different projects, but this is what I was a part of. We made a coloring book, and I have one here. So this was actually made, the District 4 Councilwoman wanted a coloring book made for the eclipses in time for Fiesta of last year. And so she had a bunch of these printed out, and the Texas Cavaliers handed these out at local schools for Fiesta. And we still have lots of these, and I also have PDFs. If you would like to look at the coloring book, or if you would like a PDF of the coloring book, I have all of that. We were also part of a project called Light Sounds that's hosted by Harvard. And so there were several of us that made these boxes. Look something like this. This is the Light Sounds box. And basically what it does is it assigns an intensity of sound to the intensity of light, so that people who are blind and low vision can experience an eclipse auditorily instead of just visually. And I have a video of that too. Oh yeah, you can't hear that at all. You can hear it on my, sorry guys, you can hear it on my computer, but you can't hear it on the audio here. It goes do 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 do. Here, okay, yeah, I'll try to. Yeah, you still can't hear it. Can you hear it? If anybody wants to hear this afterwards, just let me know and we can play it from my computer. So that was the Light Sounds projects. And then I personally was involved in another project called Eclipse Soundscapes, which the projects are slightly similar but have two different ways in which you can have people who are blind and low vision interact with eclipses. So the Soundscapes, which I am actively a part of, is a project in which we are recording the sounds of insects and animals during eclipses, because it's been shown that animals such as birds and then insects such as crickets, grasshoppers, cicadas will change their behavior during eclipses, and so we can record that and in that way kind of auditorily or have people experience an eclipse in a way that isn't just visual, it's also auditory, and then you can also kind of feel something different, hear something different. And this is a NASA Science Activation project too. So that's how I heard of it, was through NASA's Science Activation program. And so part of what I want to talk about soundscapes is that if anybody would like to be involved in soundscapes, you totally can. Just let me know. There are different ways that you can be involved. Ideally, I would just hop on, log on to the website, but all I can do for these purposes is just screenshot the website. But there are different ways that you can be involved with the soundscapes. One is basically as an apprentice, that's just kind of like learning about soundscapes or learning about eclipses. And then one is as an observer and one is a data collector. For the observer, that just means that you go outside and you write down what you feel and what you experience during eclipses, which is the temperature drops, the crickets stop, the grasshoppers, I don't know, do a thing, the cicadas make noise or don't make noise, birds stop flying, birds start flying, you know. And so that's the observer. And so if you would like to participate, like actively participate in NASA science, you can be an observer. The other way to do this is by a role called data collector. And that is where you actually get this recording device and you go out and you put this somewhere by a lake. One of my friends put it by a beehive over at McAllister Park. And you can put it by somewhere where you can pick up the sounds of animals and insects and record that during the total eclipse. So we already did this for the annular, but we're looking forward to doing it to the total. My role, I am a facilitator, so I connect the Soundscapes project to Central Texas. And so where have I gone? Here are all the places that we went for the annular. So we included McAllister Park in San Antonio. We tried to include the zoo, but I was told actually right before this talk that those were just intentions. That pink dot just stands for, that's just a placeholder for my intentions. I intended to collect data from the zoo, but we didn't actually do it, sorry. But we did collect data from McAllister Park, Guadalupe State Park, Old Tunnel State Park, Enchanted Rock, South Lano River, Garner State Park, and then down here we have a couple of other places that had one of the devices, but it's not necessarily connected to me. So looking forward to the total eclipse, we are expanding our presence in Texas to not only those places that we had before, but we're also expanding up to Dallas. And then we're gonna have some observer units in Eagle Pass and Del Rio. And we already had some in Uvalde, and then we're adding Government Canyon, and then another place over by Enchanted Rock. So we're gonna have a bunch of people all over the heart of Central Texas, collecting data on bugs and birds. And so another project that's kind of tangential to this is basically like a few of us have been interacting with Sul Ross State University, which has campuses in Uvalde, Eagle Pass, and Del Rio. And so not only are they getting some of these audio moths, the recording devices, but we're also working with educators in those communities to be part of the observer role. And then also there's some educator resources. So if you are an educator or you know an educator and you're wondering how to incorporate these eclipses into your classroom, particularly the total eclipse since it's coming up, particularly the April one, then you can go to the educator resources part of the website, and they have a lot of resources that align with, this is called Next Generation Science Standards, but in Texas we call it TEACS, if anybody is familiar with what TEACS are. So basically, like, you can use these resources to incorporate things into your classroom that are like blessed by the state of Texas as things that you can teach kids. You can tell I'm not an K through 12 educator. All right, so looking forward to April. What are we going to be doing other than we're still going to do the Light Sounds project, the Soundscapes project. What else are we doing? So we actually have a Nobel laureate that's coming to UTSA on April the 4th. So there's a public talk at UTSA from Nobel laureate John Mather. He's the person in charge of the Koeppe satellite, which mapped out the cosmic microwave background. And he'll be giving a public talk on Thursday the 4th. We are also going to be at an air show. There is an air show April 6th and 7th at Randolph Air Force Base. Let's see, we've got another video. This was the air show in 2022. Some fancy planes flying around. There are about 500,000 people total in attendance in the air show in 2022, so we're looking forward to having a presence there and handing out. We're going to hand out like maybe 1,000 or 2,000 Eclipse glasses, but that's going to be like a tiny fraction of the people that will be there. We have one person in here that's involved with Citizen Kate, that's Michael, but I say that. I know that Citizen Kate is a SWRI project, but it's run out of SWRI Boulder, and I know that Southwest Research had a big hand a couple of weeks ago in doing like the training. But some of our educators that we're partnering with in Uvalde and Eagle Pass are also going to be involved in Citizen Kate. So for the day of the total eclipse, there will be an event at Wolf Stadium. That's mostly for kind of K through 12 kids. It's not necessarily for the general public. There's something that's being planned at La Cantera, as I understand it right now, and I can get a head shake whether I'm right or wrong. The weekend before, on April 6th and 7th, there's going to be some events at La Cantera Resort that we are going to be a part of. Is it open to the public? It is not. It's only for resort people. So if you want to be a resort person that weekend, you can take part in that. And then I think on the day of, there might be something at La Cantera that is open to, again, maybe school kids. That's a Chris Packham thing. Northwest Vista. Northwest Vista has an event open to the public on April 8th. So if you need somewhere to go, if you live on the southeast side of town and you need to go to the northwest side of town, Northwest Vista is going to be there. And is that in partnership with Koeppe? Koeppe will be out. So, okay, I wrote this before you texted me back. So Northwest Vista is in totality. You can go watch it there. UTSA is also in totality. However, we don't have enough parking for everyone, so we can't open to the general public. So if you have some friends at UTSA and you want to watch from UTSA, get your friends to bring you on campus. But yeah, literally we don't have enough parking for that many people. I think, oh, look, let's play this again. There. All right, so happy total eclipse, everybody. If you have anything that you need or like you want us to add to our calendar, you want us to advertise, please email me. Myself and Dr. Speck are the point people for eclipses for April. So if there's anything you need, have a question, want to be a part of, let me know. If you want to be part of Soundscapes or know an educator that wants to be a part of it, let me know. Thank you.
All right, thank you, Lindsay. Sorry about the delay of getting the number. I was going to try to do it on the television, but the television currently doesn't have power, so that's kind of important. So the number, I just put it up there, so feel free to text any questions you may have, and I realize I don't have the phone with me, but that'll give you time to get stuff in. I do have one to start off with, and that is, are there any bugs or regions where Eclipse Soundscapes is particularly interested?
Not necessarily. They're interested in basically everything. So I know that in the parks that I'm working with, like I said, McAllister Park has like a bee tree that they put their device near. I know that South Atlanta River had like kind of like an aquatic area with tall grass where they put one of their devices. But there isn't specifically one thing that they are focusing on. So for example, I know that like one year in Arizona, there was like a cicada study. So it's not like that where there is one bug that's going to be out at this one time that they really want to focus on. It's just basically like whatever you got, they want to hear it.
Cool. Thank you. Let's see, I don't have any. I hope you all are texting. Yes, there we go. Do we have, or do we plan to get data from the bat populations for the total eclipse?
So that's, actually that reminds me, I'm supposed to get in touch with Bracken Cave. But Old Tunnel State Park, the Old Tunnel literally houses a bunch of bats. So that is one of the places that we put one of our recording devices in Old Tunnel State Park. Yes, Aaron.
If somebody wanted to be, was it not the analyst, but the other data?
Like like the one who just writes down what they see?
The one who gets the device.
A data collector, yes.
If someone wanted to be a data collector, do you get assigned some location, or do you offer up your location?
You offer up.
Okay.
You have to, I don't know all the places that you can go. You have to know, like, oh yeah, there's a place a mile away from people that I can set this, and there's some crickets, yeah.
What was your favorite outreach opportunity?
It has probably being in Uvalde. So I know that, like, I mean, I can't call it that's a horrible thing to say, that like my favorite thing was like being a part of like the Uvalde community, because obviously. But I do know that the after school program did receive some of these coloring books. So I mean, that made me feel like I'm doing my part in helping that community. So yeah, I mean, yeah, as tragic as it is, yeah.
how does the light to sound device know when an eclipse is occurring? So I guess how does the device function? And then, yeah.
Yeah, so there's a sensor in the back of the device, in the back here, and so this detects a change in light, and so it detects a change in the intensity of light, and so it assigns a sound to the change in intensity. So basically, you just have a CCD camera here that collects photons in different pixels, and so the intensity of the photon is assigned to a sound. So as the moon is moving in front of the sun, then you have fewer photons that are hitting that sensor. Yes, sir.
The progression of light intensity during an eclipse is very slow. How is that converted into audible sound?
I tried my hardest to have you listen to the change in sound. Although you're right, there is a difference between somebody holding a flashlight up to that thing, you know, woo, 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 and then actually translating that into an eclipse. I'm going to point you to the Light Sounds website. It's literally like lightsounds.org, I think, something like that. It will explain and have more video, more of an explanation to that than what I have, because I personally did not have that device on Eclipse Day, or I didn't use the device on Eclipse Day, but they do have samples of that device being used on their website.
Break. Can you?
Yes? Oh, okay.
So when we talk about that light intensity, am I not loud enough? Okay, so although the light intensity seems to change very slowly, actually for the total eclipse, the last minute, the light intensity changes hugely. So although it's a very slow progression as the moon is moving in the way, the change in light over that last minute goes from sort of an overcast day to full moon dark in 1 minute. And so you get that change in sound very rapidly over that last minute.
But you hear sound at the rate of 1,000 times a second. 1 minute is not fast for the ear. There has to be some kind of frequency modulation or translation of frequencies.
I think it's just, as I understand it, it's just slower. So like if we could hear the device, it was like woo, 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 you know, based on a few seconds. But I think so I think for the total eclipse, it does the same thing, just slower. Ooh, ooh. Like that. Okay.
We do have to move on to our next thing. So let's thank our speaker, Dr. Lindsay Fuller, once
Yeah.
again. We are now going on a 10-minute break. Please feel free to keep ordering food and drinks. We also have our merch table up here, which I invite you all to check out. We've got still some shirts and some mugs, or pint glasses, I should say. Hopefully we'll order more soon. I know we keep threatening it. And when we come back from break, we will have astronomy in the news. So 10 minutes. We'll see you then. Only smalls for the shirts. So, yay me. We have Caleb Guimar from the UTSA SWERI graduate program, and also helps out with the Curtis Vaughan Observatory. Yes, I remember the name. Here to give us astronomy in the news for the month of February. So without further ado, Caleb.
Thank you. So, yes, once again, my name is Caleb Guimar, and it is nice to be here once again this evening presenting astronomy news to you. So, let us begin. First off with what is in the... Oh. No, it's on. I got it. There we go. Okay, yep. All right, so the February skies. So if you go out at around 9 o'clock in the evening time during much of this month, you're basically looking at a perfect wintertime sky. The constellation of Orion the Hunter is placed right over the south. You can find it best by those 3 bright belt stars right in a row. Follow the belt down toward the left-hand side. It leads to the star Sirius, which is the brightest of nighttime stars. No other star except our own sun outshines it in the sky. Follow the belt on up to the right-hand side. It leads to that very bright red-orange star called Aldebaran, the evil red eye of Taurus the Bull. So if you look around the sky, there's actually quite a bit to see. Find a really good dark sky to observe under. The planet Jupiter is still very much visible. Yeah, I know there's some Jupiter folks in the room. There we go. Jupiter is still very well visible. Look over toward that western half of the sky. You will find an extremely bright star-like object over toward that western half. That is the planet Jupiter. Very easy to find, but do look at it throughout the remainder of this month, because as we head on into March and April, it will get lower and lower toward the west, and it will become a lot less readily seen in the sky. Now, if you have a pair of binoculars, look for that belt of Orion the Hunter, and beneath the belt you'll find a very faint sword kind of mounted in the holster on the belt. Well, if you look at that sword with a pair of binoculars, there's not necessarily a group of very distinct stars there. There's a couple of fairly distinct stars and a little fuzzy spot. That little fuzzy spot is the Orion Nebula. This is a star-forming region of hydrogen gas mostly, a little over 1,500 light years away. So you're looking at it as it appeared a little over 1,500 years ago. Very easy to see in binoculars. It is a place where new stars are forming as we speak. Please find a dark sky, look at this with a pair of binoculars. You will not regret it. And not only that, do take a look at many of the other deep sky objects that are scattered across the Milky Way there in the sky. Many nice open star clusters visible during this time of the year. So now for the first news story up. Many of you have probably heard about some of these little incidences, but nonetheless, it's been pretty hard times in the solar system over the last month. We've had a couple of robotic moon missions. One of them called Persian 1. This was a joint effort between Astrobotic Company and NASA to land a small economical lander on the lunar surface. It did not successfully land on the lunar surface. The rocket launch for it, the first launch for the Vulcan Centaur rocket, was actually picture perfect, but the probe itself, the thrusters on board, basically had a very severe malfunction, and it was not able to actually land on the surface of the moon. Alternatively, though, JAXA recently, the Japanese Space Agency, had a little better luck. Their mission SLIM successfully landed a couple of small rovers on the moon, and they sent back this image of the lunar surface and this probe right here, the main probe, and that's where the problem was. It landed upside down. Yeah, you can see the main thruster right there pointed up instead of down. Yeah, so somewhat successful, somewhat not, but nonetheless, spaceflight is not easy. Now, at Mars, we had a goodbye of sorts, but it wasn't a terribly sad goodbye because this actually way outperformed all expectations in the beginning. The Ingenuity helicopter is part of the Mars 2020 mission, which included the Perseverance rover. That helicopter has been operating very well for the past, probably a little over 2 years now. And on its most recent flight, it had a rather hard landing. The one part of its propeller blade, which you can see in shadow right here, was damaged toward one end, and it is no longer flyable. So that marks the end of Ingenuity, but nonetheless, it has been a great run with that spacecraft. A big kudos to the folks at JPL for being able to pull that off. Yeah. And this is one of the final views from that helicopter in one of its latter flights. A beautiful view over the sloping Martian terrain there. So the Hubble Space Telescope actually has contributed to a number of recent discoveries, but this is one that happened to catch my eye. It actually observed this exoplanet named GJ9827d. I really wish some of these things had some more illustrative names, but nonetheless, that exoplanet, which is around a red dwarf star about 97 light years away, is oriented to us in such a way that we can actually, with the Hubble Space Telescope, observe it passing in front of the star, and we can see the spectra of the light passing through its atmosphere. And using the Hubble Space Telescope spectroscopy data, the group of scientists on this project that this is part of were able to see that there was water vapor present in the atmosphere of this extrasolar planet. Now, this extrasolar planet is actually a rather interesting world because it's not too far off from being Earth-sized. It's about 2 Earth radii, approximately. And then not only that, it's close enough to the to its parent star that it should have a fairly temperate environment. Now, it may be too temperate. It's very likely a Venus-like world. Over 800 degrees Fahrenheit at its surface. Terrible, terrible place. And it's not clear whether the water vapor is in its upper atmosphere or if that water vapor is part of the lower levels of its atmosphere. A lot of work left to be done there. But nonetheless, a very remarkable discovery from the Hubble Space Telescope. Now, here's something I always like to highlight. I always like to highlight instances where amateur astronomers contribute to astronomy. And so an amateur astronomer in South Africa a couple of years back discovered a supernova in a distant galaxy. This galaxy, NGC 157, is about 75 million light years away. That's somewhere in the neighborhood of about 455 million trillion miles away. I'm thinking of taking that trip tomorrow. How about the rest of you? Yeah, all right. Anyway, but nonetheless, though, you can see in this galaxy the supernova right there, and follow-up observations by the VLT and NTT. NTT stands for New Technology Telescope. Actually, notice that this supernova did not dim down gradually like what most supernovae do. This particular supernova went through these kind of odd oscillations as it was dimming, a period of about 12-day oscillations. And this implies that there is a partner in the system. Why is this significant? Well, it's significant because until this particular observation, usually you were basically seeing the remnant of the supernova after the fact. And coincidentally, you would find neutron stars, maybe black holes in the regions, but there was never a time where you really observed the remnant itself, the high-density former stellar core there in real time after the formation event. In this case, because it has this this binary companion, which is probably collecting gases and going through these weird outburst events, it was able to reveal that indeed there is this very high-density remnant there, likely resultant from the supernova explosion. So this was a really fascinating discovery, and again, just amazing that you're seeing something from that far out in space. So, some do not miss events. One, obviously, the total eclipse. We heard about all of that. Yeah. Once again, just be aware, be in the right place. Do not be on the wrong side of town when this happens. You want to be on the northwestern half of San Antonio when this takes place. We do have a Friday night Celestial Lights. That's a lecture at the at UTSA. It's in the Flound Science Building there at UTSA where the observatory is, followed by star observing there, weather permitting. Hopefully the weather pans out this weekend. I'm just not sure it's going to happen, but we still will have a lecture, so maybe you'll get an interesting talk out of it. So do indeed show up to the UTSA campus, Flound Science Building, this Friday evening. I think we usually do those around 7:30 in the evening time, and you'll be able to have a kind of interesting educational event to go to. And then there's 3 NASA launches this month. The PACE mission, which is an Earth Sciences mission, is launching tonight at 12:30 a.m. So tune in online. NASA television should carry the launch. We also have another attempt at a economical lunar lander, the Intuitive Machines 1. That's going to be on February 13th at approximately midnight when that will launch. So let's hope that one goes a little better than what the last couple have went. And then there is a NASA SpaceX Crew 8 mission to the International Space Station, currently slated for sometime late February. We'll see if that stays on schedule. And finally, I will leave you with these 2 images. One of them is from the Juno spacecraft. Yep, this is of Io, the innermost moon of Jupiter there, very, very active world volcanically, and you can see the nighttime side and Jupiter shine here and the daytime side illuminated by the sun. This is an awesome image. That's from a distance of roughly 900 miles away from that moon, which is one of the closest approaches ever. So really, really fascinating stuff. And then this image right here is a 1.5 billion pixel image of what's called the Running Chicken Nebula. Don't ask me why they call it the Running Chicken Nebula. But nonetheless, though, yeah, you can kind of see it. From the very large VLT survey telescope, fairly recently brought online observatory. Really beautiful image here and high resolution. Look that up online. It's really awesome. And that is Astronomy in the News. Thank you very much, and enjoy the rest of your evening.
Thank you, Caleb. Give that to Dana. Wait. Oh, give it to Dana. All right, Dana, for reference, down is forward, and then the little light thing is a laser pointer. That's a laser pointer, and then down moves the slides forward. All right. As we get the slides, I'll just start the bio. So our next speaker is Dana Koeppe. She is currently a postdoctoral student over at Johns Hopkins University in Baltimore. She went to both undergraduate and graduate school at Michigan State University, Spartans, I believe. Yeah. While she was there, she researched galaxy clusters, which I believe is the topic of this presentation. And she's currently working at Southwest Research on an instrument called Scorpio, which I believe is a ground-based telescope that would be in the mountains of Chile, South America. And she hopes to observe with this telescope in the future. So, Dana, what is your drinking word?
Metal.
Metal. Did you guys hear that? I said it. Yeah, okay. All right, without further ado, please welcome Dana Koeppe.
Hello, everybody. So I know this is called Cosmic Giants, and that is because galaxy clusters, they're one of my favorite things to study, and it's because they are the largest gravitationally bound organized structures in the entire universe. And just to give you an idea of how large they actually are, here's the Earth, about 1 light second or so in diameter. And then we can go to our solar system. We can just zoom out a little bit. So I'm going to zoom out until we get as far away as we can. Come on. Whoop. And then we have the interstellar neighborhood. And so we have these stars that are sort of closest to us. You might have heard of like Proxima Centauri, stars like that. And then we have the Milky Way galaxy. So that is our home neighborhood. So if you ever see any pictures of the Milky Way galaxy, we can't actually observe our own galaxy because we would have to go out really, really far in order to get a good picture of it. And so usually they're just artist renditions of them. But this is an example. And then, so that's about 10 to the 5 light years in diameter. And we have the local galactic group. So that is just a small sort of group of galaxies that we are all connected to. But then we have the Virgo supercluster. So this is a large, it's a cluster of clusters basically. And it was discovered, I can't remember exactly, but it was within the last 100 years or so that we were able to tell that our galaxy was connected to all of these other ones. They were gravitationally bound to each other. And so our local supercluster is the Virgo supercluster. And so that's about 110 million or mega light years in diameter. And so we have more local superclusters. Zooming out, and you can tell you don't have to focus so much on the actual text there because it gets so far out that we can't even see which one is this one? So this is just basically where we are in reference to the observable universe. So you can tell how large it is. But I actually have a better, and that was 28 gigalight years across, and that is our observable universe. And just a better representation of how large this is, we have a flight through the cosmic web, and this is a simulation done at the University of Illinois. And the purple stuff are the filaments that connect all of these galaxies and galaxy clusters to each other. The white stuff are the actual galaxies. And so this is a time span of a length of about 437 million light years. And it's pretty cool. It's sort of like a 3D rendition of what it would look like if we were zooming through space, through our observable universe. So just to get a sense of how large it is. And notice how it's not totally uniform once you get to the smaller bits, but as you go out, the universe gets pretty uniform with all of its clumping. Okay. Yeah, it's the largest telescope we ever made. Okay. All right, and so what is actually the composition of these galaxy clusters? So what we see, what we're able to observe, the visible light from these stars and from the stars that are actually in these galaxies, it's only about 5% of what makes up these clusters. 80%, about 80% is dark matter. And so how do we know that? Oh yeah, and the rest of it is hot X-ray plasma, and I'm going to get to that in a little bit. But first I want to talk a little bit about dark matter. How do we know that it's so prevalent? Because it's dark, we can't see it. We can't actually observe it directly. So we're able to know that it's there through its influence through other massive things. And so we discovered this. So this is a rotation curve of M33. So if you have heard of the spinning ice dancer, and so when they put their arms in, they spin a lot faster, and they put them out, then they spin slower, and that just has to do with angular velocity or angular momentum. And when you have more mass concentrated towards the center, that's how you're going to spin faster. But when it's more distributed out, you're going to get a little bit slower. So what we expected based on what we see from all of the stars, you see more light towards the center, so you expect there's going to be more mass there. You expect it to actually rotate a little faster towards the center and slower towards the outskirts. But what we expected did not match what we saw. So from the visible disk and then out here, from observations, it did not match what we thought we would see. And this is just an example of what we expected it to look like. So over here, with the rotation curves just based on visible matter, you can see that everything in the center is sort of spinning a lot faster, and then as you get towards the outskirts, it's not going as fast. But it sort of flattens out in what we actually observed. And the people who saw this were Vera Rubin and Fritz Zwicky. That's hard to say, Fritz Zwicky. He was one of the first people to sort of notice this, and then Vera Rubin came along and actually put everything together, and that's how we know that dark matter exists. Something else had to be out there that was massive enough to see these rotation curves. But I'm not really going to focus on that. I know everybody likes dark matter, dark energy, and all that stuff, but what my interest lies in is the hot X-ray plasma. So this is a gas that permeates the intracluster medium, and it's pretty much everywhere. We didn't know that this was existing before, and once we had X-ray telescopes, we were able to see that it's not actually empty space that's there. There's a lot of plasma, a lot of hot gas, and it actually is comprised of metals. And we can see that they're there from the spectra of these galaxy clusters. And so we know that they're the largest gravitationally bound structures. They are mostly made of dark matter, but we have this hot X-ray gas that's invisible to the human eye, but we can see with X-ray space-based telescopes when we view it with that. So, come on. There we go. So here is an X-ray image of 4 different clusters. The Abel clusters, Abel was one of the first people to sort of look and catalog what he saw in the sky for all of these clusters, and so it's called the Abel catalog. There are a bunch more now, but as you can see, there are different types. They look sort of different, and then we can also overlay the optical images and just get an idea of what's going on in there. So this is an image, so these are actual Chandra X-ray images from their archive of a couple different clusters. So not all of them are the same. Some of them can be very diffuse, or some of them can have very concentrated cores. And so that's what we're seeing here. Abel 2390, this is something that's known as a cool core cluster, and what that means, I'm not gonna get too much into detail, but basically the gas there has cooled and condensed enough where it just sort of settles in the center of the cluster. Whereas if you have something like Abel 2219, that's a non-cool core cluster, it just means that the gas is more diffuse. It maybe had a merger, it has an active galactic nucleus that's sort of pushing out all the gas, and it's not allowing that gas to cool and condense. And what's actually cool about cool cores is we can see evidence of star formation in a lot of these. There's actually a correlation between how cool the core is and how much star formation we can see in them when we look at that through the spectra of these things. And so one of my favorite examples of a non-cool core cluster would be the bullet cluster. And so that is over here, and you can kind of see the shock wave, and you can tell that it's basically from galaxies merging together. And when that happens, everything gets disrupted, and you're not gonna get a nice, cool, spherical sort of shape in the X-ray image. Whereas here, you see this little core, and we'll usually see like a brightest cluster galaxy. That's what we call it. It's the cluster, it's the galaxy that's sort of in the center of the cluster, and that's where we'll usually see that star formation happening. Oop. And so we can actually quantify this in what we get from the spectra of these things. So we can get the temperature or the surface brightness here, so you can actually see the difference between these cool core and non-cool core clusters. With the cool core, Abel 2390, you can see how the temperature dips, and that also causes the surface brightness to go up because you have just more of that gas that's settling in there. Whereas non-cool core clusters, you get something that's different. You have a higher temperature and a lower surface brightness that's there. And so I've blocked these out because when you get out to a certain distance, when you're away from the core, it actually sort of evens out. Most of these clusters look pretty much the same. And, where is it? And we can also see this in the metallicity of the cluster. And so, yeah, we measure this from the X-ray spectra of the clusters. So it's we look at an iron line in there because when stars grow and die, they emit all of this extra metals. Basically, in astronomy, anything that isn't hydrogen or helium is called a metal in astronomy. And so we are looking at that. And you can see that as you get closer towards the core, in a cool core cluster, that jumps, that metallicity jumps. All right, I said metals, not metallicity. Okay, so you can see that the slope of this increases a lot once you get towards the center, whereas it's a little bit flatter when you're in a non-cool core cluster. And I thought that was really interesting. Other people thought that too. I'm not the first person who discovered this, obviously. And when you see them stacked over each other, just to get a better visualization of what these look like, once you get out about 0.3, so this is just a distance measure that we use. I don't need to get too much into it, but outside of the core, we see that they line up a lot better. And we can infer how this happened based on different images from different wavelengths. And so with this, you can kind of see, this is an X-ray image of a cluster called Hydra A, and you can see these little gaps here, or these little bubbles. And if you actually overlay it with a radio image, it also includes the optical image with all the stars and the galaxies, we can see what is responsible for making those bubbles here. And this would be an example of an active galactic nucleus. It's actually pushing out material from the black hole, or from the dust and gas and everything that's around the black hole. And it pushes everything out, and that's how we would get a non-cool core. And so this is the illustrious TNG simulation it's a collaborative effort to sort of take these observations and then put them into models so that we can predict what's going on, the evolution of these galaxy clusters, and see maybe what would happen. And then it also goes backwards. We can look at our observations and see how they compare to what these get, and then we modify the models based on all of that. And so this is just an example of one of them. So this is for a galaxy to sort of see what happens when you have an AGN feedback, is what it's called. So feedback is you have gas and dust that has fallen onto the black hole, and now it's getting pushed away. There we go. And so I like to focus on do I have to turn it on again? Put it in. Okay, well, I like to focus on the metallicity here, and you can see how it sort of gets distributed throughout the galaxy. But thank you. You might be asking why we don't see the same trends, the same differences between cool cores and non-cool cores that we see in the center. Why don't we see that in the outskirts? Thank you. And that's because galaxy clusters are really big, as I said before. They're enormous, and it takes a lot of time for all of that gas to migrate out into the outskirts of the cluster. And so we can't really see evolution with respect to redshift. So redshift is basically distance and time, how far back we're looking at something. We can't really see it with at least the samples that I have, that I've been looking at, and that we have historically been looking at. JWST has changed that. I think I actually saw a paper, a recent paper that was published that looked at much higher redshift galaxy clusters, and it looked at the metallicity in there to see how this metallicity evolves over time, over longer time spans. I didn't get to read the whole thing because I only just saw it today, but you can Google it. It's pretty cool. But what I've done before, so this is a sample of over 300 galaxy clusters that I've been looking at, and just collecting the data, trying to see if there's any evolution in that enrichment content of the clusters, to see if there's any dependence on redshift. I also did check to see if there's any dependence on luminosity, but I'm not going to focus on that. It's not the prettiest plot, but you can tell that nothing's really happening. You don't really see any trend with respect to redshift here. So this metallicity is on the y-axis, and then redshift is on the x-axis, and it's just pretty much a blob. You can't really see any trend there. And then when you actually fit all this data to a model, that's these numbers over here. We don't really see anything that's significant. There we go. So if we want to look in the future, we want to get more data, more galaxy clusters, more spectra from these, we would need better observatories in order to look at them. And so, yeah, the lack of evolution with respect to redshift, as I said, we just need more clusters that are further out. So JWST is capable of seeing these things, and it would be, that's one of the papers that I mentioned. We're able to look much farther out, because by the time a lot of energy has left, it gets redshifted, and then we can see it in the near infrared. It's not just the X-ray spectra. We can also look at something called H-alpha emission lines. That's usually evidence of star formation. And so, just a nice picture of JWST. And then we'd also like to get some much higher resolution X-ray observatories. So Chandra, it's pretty good, but it's not the best. If you want to go further out, you would need to actually resolve the core from the outskirts of the rest of the cluster. And so something that would be really good for that, it's just a concept right now, but I'm really interested in it, is LINX. The LINX Observatory is a proposal, or just a flagship mission right now. So they haven't really done any actual building of it. It's just a concept, but it would be a super high resolution X-ray observatory so that we would be able to do things like this. And that's about it. That's my cat Guster. He's a ghost now, but he's a good ghost. But yeah, if you have any questions, please text the number.
All right, thank you, Dana. Hello? Hello? Thank you, Dana. Our first question is, do you get guaranteed observing time with Scorpio due to your involvement?
That's a good question. I hope so.
Will you get? Yeah.
I hope so. I mean, I think I should. It depends on my position with the observatory later. I did get guaranteed observing time with SOAR, because SOAR is a different observatory that's around the same area down in Chile. And Michigan State is partial owner of it, and so we actually get time on that we have to request it, but we're guaranteed some amount of time, so we get like the first dibs on it. I think Todd had a question back there.
I was just going to point out that you get 12 nights of guaranteed starting time, city part of Scorpio.
Hype. Yay. Oh, okay, never mind.
What?
We will deliver on time.
Oh, okay.
We
So
will.
if you deliver on time, 12 nights, that's good.
Perfect. That's all.
12 may not sound like a lot, but it's actually like pretty.
It's
good.
huge.
That's good. All right, I love this question. I know who sent it in, so I'm going to try to read it the way they intended it. Why are they called non-cool and not hot?
That is a good question. I don't know. I think it's just to distinguish them, so it's easier to just say, okay, we have a cool core and a non-cool core versus a cool core and a hot core. It doesn't have quite the same ring to it, but it doesn't just have to do with the temperature. It's something called entropy, and it scales with temperature, but it also includes the electron density in there. And so we're talking about the temperature as well as how concentrated all of that gas is.
Thank you. This next question is, why does the hot plasma seem to be one large chunk near the center of the supercluster, while the galaxies themselves are clumped in many different locations?
So the central, I think I'm understanding this question right. So the central galaxy, or the brightest cluster galaxy, it's usually the most massive. Maybe it doesn't seem like the most massive, but you can usually match up the largest, brightest galaxy with the center of the cluster, whereas there are some other galaxies in the outskirts that are usually being drawn towards it just gravitationally. But you will see some little clumps just because of random things that are happening around there.
Why does the metallicity plot go further inward on cool clusters and versus the non-cool clusters?
That's a good question. Oh, I turned it off. There we go. Okay, so yeah, you're talking about this one here. Okay, so this is because it requires a certain amount of material in order to get a good measure through the spectra of whatever's going on there. And so with non-cool core clusters, since it's less dense, there's less gas for us to actually observe in there. It's harder to get a good read on what's going on exactly in the core.
This is my own questions. Are cool cores cool?
I think they're pretty cool.
I asked that because there's no new questions. There's no new questions.
They're cool to me.
I'll read this one and then I'll get to you. Do scientists ever refer to metallicity versus redshift graphs as ZZ plots?
So I haven't heard it spoken, but sometimes in a paper or something, it'll be like a Z dash little z or something. But it's not very, no, probably not. Just because you have two Z's, and it might get a little bit confusing, even though one is like a capital Z and one's a little z. But yeah, it's usually metallicity or redshift. Metallicity, redshift.
Has anyone measured the velocity curve in the X-ray part of the spectrum? You indicated there's a lot more matter out there or there's a lot more X-ray photons than there are visible photons. So you would think that would be part of research?
So are you talking about so back here with the speed of the matter that's going out there? So that I'm actually not sure of. I'm sure with the X-rays, because you do need to look at you can look at the spectrum in order to see that, but from what I know, they looked at a different part of the spectrum, and I'm not sure. I don't think so. I'm not sure. But that's a good question. I'll probably look it up after.
What is the biggest structure that's resistant to the expansion of space? Is it these clusters as far as the gravitational boundness?
Yeah, so these clusters so when I say they're the largest gravitationally bound things, they're the largest things that are able to sort of resist that negative energy pressure, or that the vacuum energy, or dark energy, which is sort of expanding our universe, accelerating the expansion of the universe. And so these are the last things that we can see that actually are gravitationally bound instead of being thrown apart.
Interesting. All right. With that, we will wrap up the questions. Let's thank our speaker once again. And that brings us to the last item of our program. It's trivia time. Woo! So we're going to go on a 5-ish minute break here. For those of you that can't stay, thank you so much for coming. We hope to see you next month, first Wednesday of March. For those of you that can't stay, we will be coming around with sheets and pencils, or pens. So give us about 5 minutes or so, and then we'll start our trivia. Thank you.
Ethane. I didn't know that was like a UK British, like a UK versus America thing. Like one of those words.
How are we on this question? Can we move on? Question 2. Magnetic sensing. After 50 years of research, scientists now believe that some, if not all, animals have a sixth sense. The ability to know the orientation of the local magnetic field known as what? A, magnetoreception. B, magnetolocation. C, radiomagnetism. Or D, echomagnetism. And this looks like a shark with a nose? No. Yeah.
Sharks have noses.
No, I know, but
Well, they have snouts.
I see. They're trying
They
to
caught a
confuse the
shark and put magnets on him. So what's your job? No, I put magnets on sharks. Did anybody see the little blurb?
blurb.
I guess not. Somebody saw it. Okay, you saw something.
What was it?
There, Sam put a little blurb in the "Did you know?"
Oh,
A little clue. A little
yes,
breadcrumb.
he always does that.
Keeps you on your toes.
All right. How are we on this question? Good?
Question 3. Finish that lyric. So don't delay, act now. Supplies are running out. Allow, if you're still alive, 6 to 8 years to arrive. And if you follow, there may be a tomorrow. But if the offer's blank, you might as well be walking on the sun. So this is Walking on the Sun by Smash Mouth. And so is the blank word expired, survived, retired, or shunned?
I know you know this.
I only know one Smash Mouth song. And it's the one. It's the one we all know.
It doesn't stop coming.
It doesn't stop coming. Did anybody listen to like any other Smash Mouth song? Like, did anybody like this one? Like,
Oh, All Star, All Star. Wait, no, that was the big one. Oh, wait, no, what's the other one? Oh, when they did the cover of the Monkees.
oh, they did the cover of the
yeah.
Monkees. Yeah, yeah. What's the cover of the Monkees?
I'm a believer.
Oh.
Yeah.
Oh, yes, yes.
That's the only reason why it's Shrek. What are you doing in my swamp? All right. Question 4. Arabic astronomy. Ancient astronomer, Abd
Come on.
al-Rahman al-Sufi refers to this celestial object as a little cloud in his book of fixed stars. Is it A, the Andromeda Galaxy, B, Halley's Comet, C, Jupiter, or D, the Pleiades cluster? And then this one will have a special bonus. So this one I want you to put next to the letter on that same line. When was the book written? And the closest answer will be given a bonus, half a point, but yeah.
Sam, is that the book of fixed stars? Is that a snapshot of it? Yes. Wow. Oh. It's pretty interesting that their written language has remained so constant for him to be able to read it. Everybody good? Question 5. In the classic 1987 film Spaceballs, Lone Star and Barf travel the cosmos in a Winnebago spaceship with a license plate that reads blank. Is it A, Spaceball 1, B, Eagle 5, C, Yogurt, D, M Falcon, or E, the USS Reagan? Wait, is it really? It's by Sam. It's Bartholomew. Yeah, we didn't go with the legal name.
His friends call him Barf, I guess. And Sam is a close friend.
Is Spaceballs one of the first parodies? Is Spaceballs one of the first parody movies?
No.
Oh, I didn't know that. Yeah. Interesting.
It's pronounced Frankenstein.
We haven't had any parodies.
All right, we're going to go to question 6, the last main question. Barely making the cut. Which U.S. state will be the last state to observe totality during the April 8, 2024 solar eclipse? Is it A, Michigan, B, New York, C, Maine, D, Massachusetts, or E, Texas?
Is it? Everybody got their guess? Time for the bonus. What are the 4 brightest Messier objects in the night sky in any order? Brightness is determined by total apparent magnitude. Let's be clear. Now, bonus on the bonus, if you correctly guess the Messier number, or if you know the number, you get an extra point for each object. So what are the 4 brightest Messier objects?
And then as you finish up, please bring up the sheet and piece of pen. Oh, that's wrong. The pen and piece of paper. And if you need us to go back to a question, wait, we can. But if you're done, bring up your paper so we know you're done. Thank you.
Does anybody need a question repeated? A Messier is a person,
Charles Messier.
and he cataloged a bunch of things in the night sky. There's about 100 and, well, he did like 100 of them, but then now there's 110. So there's 110 things in the sky, and which of those 110 things, which are the brightest?
I have a poster in my apartment that has every last one of them. Just putting that out there.
Or like the objects? Oh, that's really cool. Everyone's good on questions? All right, as Michael said, whenever you're ready, bring up your paper and pen.
All right. Reminder to bring up your sheets when you're done.
We need the sheets. Please bring them up when you are done. We need the sheets. Has everybody turned in their trivia sheets? Tiffany? I need your trivia sheet. Thank you.
You're welcome.
Is that my pen?
Yes, it's your pen.
We're limited on resources.
All right,
The-
everyone. Now we go through the answers.
The answers shall be revealed.
Question 1.
The answer to number 1, what is ethane? C2H6. I know nothing about chemistry and nothing about the anes.
So C2H2 is acetylene, C2H4 is methane, and then C2H6 is ethane. So it's 246. It may sound like chemistry to you, but in planetary science, these are important too. So worlds colliding. Question 2, which was about the magnetic shark. The answer is A, magnetoreception.
That was the MR in the blurb that Sam put up in the first
Yep.
break.
So now you know that sharks may be able to tell the magnetic field. I don't know. Birds? Some, if not all.
So what we learned is when you go to the beach, take a magnet with you.
Some, if not all, because humans, I don't know the orientation of the magnetic field right now.
Well, that may be why they have the whole thing punch the shark in the nose kind of thing.
Maybe.
I mean, if I punch you in the nose, you're going to get all...
All right.
I'm not going to punch you in the nose.
Question.
Question 3.
Smash Mouth.
Huh? Oh, it's Smash Mouth. The question, what was the blank lyric from the Smash Mouth song? Shunned! They just completely threw rules out of the window. Doesn't rhyme with anything. Okay, yeah, in the last, I guess. Because I would have gone with like, oh, arrive, revived, or survived rhymes with arrive, but it's Smash Mouth, so.
It was an interesting era of music. Question 4, which was about the Arabic book. So not only did you need to know the answer, but we asked you to guess the year that the book was written. A, Andromeda Galaxy, and the bonus was 974 AD or CE, depending on your nomenclature. But yes, the Andromeda Galaxy was referred to as a little cloud because if you go out and look at the Andromeda Galaxy, it'll look like a little cloud in the sky. I recommend it if you ever get to a dark sky. Caleb knows. He's doing all this all the time. But it does look like a little cloud. And the most intriguing part of it is that every little bit of that cloud is a star. So it kind of freaks you out. I'm not going to lie. It's freaky. All right, question 5.
Question 5 was about
Spaceballs.
Spaceballs. What was the license plate? Eagle 5.
There you go. I have never seen this movie.
I've seen it once, and I had a guess it was Eagle 5, but only not because I saw it, but because it just sounded right. It sounded like correct from the references.
So the next question, the last question, question 6, about the last area to get total eclipse upcoming in April. I thought it was New York because I thought it was going up to Canada after that. It must straddle the border between Quebec and the U.S. state that we call Maine. So, yeah. I
the
would
sun's
not
going.
recommend going up there. I would not recommend going to New York. I would not recommend going to Maine in April to see it because those places are too damn cloudy. Stay in Texas and watch the eclipse from here.
Enjoy all millions of the people that are going to come on that day to watch the eclipse.
Yes. All right, the bonus. The big bonus. Ready?
What were the 4 brightest Messier objects in the sky? They are M24, the Sagittarius Cloud, M31, the Andromeda Galaxy, M7, Ptolemy's Cluster, and M45, the Pleiades Cluster.
Very good. All right, those were the answers for today. So, without further ado, it's time to give out some prizes. In third place, winning this lovely poster and a sticker. Was there anything? No, just this and this is Dana. Bring it back to your office, yes, and maybe make your hotel room feel like home. Our second place winner, which will win the mug shown here, called, it says Drink in Totality on it. It's in honor of the annular eclipse, but I mean, it's still cool, you know. You know, don't question it. Don't question it. Hydrogen alpha filters. H-alpha filters.
Oh, yeah. No, you did. Yeah.
And then the grand prize tonight, which will go to which will include the 4 prints that Robert Reeves brought and discussed today. Once again, thank you, Robert. Dungeons and Dragons. Okay, it's going to a good home. I know that much. It's going to a good home. These prints, congratulations. Our first place winner of the night. These prints are really special, and I know that I hope to see them in your offices. If I don't see them, I'm leaving. Thank you. Thank you, everyone. Thank you. One more slide. All right. Thank you for coming tonight. I hope you all had fun. We will be back on March 6th. That's the first Wednesday in March. So we'll see you then. But between now and then, please make sure that you're on our email list Come check out our merchandise if you haven't already. We have some more posters and stickers if you're interested. And special thanks to the Blue Star Brewery, as always. Thank you for hosting us. Thank you for the wait staff for everything that they do. The Southwest Research Institute for their support in putting on this event. And the UTSA for their support for putting on this event. So thank you all. Have a good night. Get home safe.